start recording. We've got our TEDs open. We'll go new. We'll go analysis, 2D analysis. Let it load up, takes a few seconds. Here we are. Right, there's rules of thumb. You will get taught these later on about other lectures, about how to do it by hand, but just go with me on the rules of thumb. Always start node number 1 at 0, 0. For this, I'm doing number 4, aren't I? So let's make sure I get this correct. I'm going to go 2 meters in, up 0. I'm then going to go 5 meters in. Is that a big wee? No, don't. Yeah. 5 meters in, up 0. Then I'm going to go 5.5, up 0. And then I'm going to go 7.5, up 0. 10.5, up 0. Oh, he's copied me. Oh, thanks, man. Right, and then the last one, 10, I think it's 11.5, up 0. So far, we've got no support reactions. Let's put some support reactions in. Number 2 will be fixed and fixed. There, we can see that's a small triangle. The next one's going to be 6 here. I'm going to support it vertically, not horizontally. Just go with me now on that. You'll learn about that later on, and you'll see the symbol has got 2 wheels on it, saying it's free in movement horizontally. If I were to fix that horizontally as well, it would change the outcome, right? You will get taught to do this by hand at some point, and when you're getting taught to do this by hand, whoever the lecturer is, don't say, yeah, I've got tech or TEDs, because it's probably going to be Bernardino that will be teaching you that, probably. And if you are, everything that he teaches you, you can double check before you submit. You also have to do it by hand. You won't double check absolutely everything. Right, okay, cool. Materials. What's he said in his exercise? He's not caring about the material. We'll just put C24 in. We'll go timber. We'll go C24. That he used before. We'll go section size. We want to give it a section size. Now, it's going to have to be quite big because it's quite a large beam, to be honest. Section. You know what? Let's go back a step. Let's cancel that now. I'll go back to material. I'll delete that just for the now. And I'll put steel in there instead. I'll put steel, Eurocode 3. Then we'll go section. And we'll just pick a section. We'll pick European steel. And it'll give us a list. And we'll pick one that I know quite well. Universal beam. 305. I used to use that one a lot. Okay. There's a massive steel beam. It's definitely big enough to do what we want to do here in real life. Element. We'll go element 1, element 2, element 2 to 3. Sorry, node 3 to 4, 4 to 5, 5 to 6, 6 to 7. Excellent. And then we'll go design member. I would just do it. It makes your life easier later on. Even though it's just a simple beam, I would just do it. Start element 1 to the last element. It automatically picks for you where you've already put your support reactions. Just for just now, say yes. Later on, you do more complicated structures. You might want to modify that, but for just now, it's perfect. We'll give it a name, beam. That's good. Loading. Right, I'm doing loading scenario number 4. What Wojtek is showing is 2 partial UDLs of different loading and 1 point load. So we'll do that very, very quickly. I'll take off self-weight and I'll take off permanent weight and I'll only have imposed load. I'll put my cursor on here so we can view what our loadings will look like. And we'll start applying them just now. We've got member load or element load. I'll go to element. I'll go element 1. Make sure it's imposed. And my loading for element 1 is 3 kilonewtons. We've got element number 2. And it again imposed. And it's 3 kilonewtons. And then element number 1, 2, 3. Oh, sorry. 4, 5. Element 5. This will actually be 4 kilonewtons. And element 6, 4 kilonewtons. And then we want to go to nodal load. And then we pick node number. In this scenario, it's going to be 1, 2, 3, 4. Node 4. Imposed. And we'll put the vertical load of 25 kilonewtons. So you see how the scaling's changed depending upon the loading. Just of the image, I mean. Now, we're not going to worry about load case combinations. You'll get to that in other years. We'll go straight to results. You are meant to report. Determine the support reactions. Well, your reactions are here. Number 2 is 30.706. And at number 6 over here, it is 25.294. Sketch the shear force diagram. There's your shear force diagram there. Sketch the bending moment diagram. You actually already had that. There's your bending moment diagram. You can scale it up if you want. Make it more meaningful. Determine the value of the maximum shear force. Well, actually, if you go to member, remember we made that whole thing as one member. You can look at this result along here. Determine the maximum shear force. Shear maximum 24.706, and there's the position for it as well. Determine the maximum bending moment. 62.471, and the position for it of it there. That's right in the middle. So that's you done all of that very, very, very quickly. You could literally do that exercise there in about half an hour, start to finish. Submit it and get those extra marks. Now, what you can do is you go output. Now, this is really quite good. You can pick and choose what you want to show. He's giving you a list of what you want to show. All you need to do for this one is literally just pick and choose the ones that you want. I'll just put some in now. Right, I've not put them all in. You put in the ones you want. And you go, okay. All you literally need to do is do that 1, 2, 3, 4. Do that 7 times for each of them. Then submit it. Take no more than half an hour. And it's absolutely bang on. How long did that take you to do in Excel? A long time, yeah? You're doing it in minutes here. I'm going to stop recording now.